Today we're taking a look at a strategy called completing the square. Now, completing the square is a method for converting from standard form of a quadratic equation to the vertex form. Now, if you keep in mind, the vertex form went like this: y is equal to a times x minus h quantity squared plus k, where h and k were the vertex of our parabola. So completing the square is essentially just that. It's going to help us to write a perfect square trinomial in which there are three terms, 1, 2, and 3, and that's essentially the square of a binomial x plus h. Let's take a look at this first example here. It says what number should be added to x squared plus 8x to make a perfect square trinomial. The way we do that was we're actually going to take a look at this visual, right, of a square, and that's where we get this idea of completing the square, where we have in our first row in column x times x, which is x squared, plus 4 times x, which is plus 4x, and then down here in row 2, column 1, we have another plus 4x, and then if we were to multiply our last row and last column, we'd have 4 times 4, which is 16. So if I add up all these terms here, this 4x and 4x, give me my 8x. And therefore, to make this perfect square trinomial, we would add this 16 in, which was the square of 4 and 4. Therefore, this perfect square trinomial is really the square of the binomial x plus 4 quantity squared. And the way we got that is we took half of 8, which was 4, because I needed to add 2 of those terms in order to get that 8x. We'll take a look at a few more examples here. All right, in example 2, we see we want to add a number to the x squared minus 10x to make a perfect square trinomial. So again, we're going to create our little square here, and we start off by just taking half of negative 10 and allowing that to be our column 2 here in our row 2. So when we square x and x, we get x squared. When we times negative 5 and an x, we get negative 5x. Same thing here for row 2, column 1. And then finally, when we multiply negative 5 times negative 5, we get a positive 25. So we would say the number that we add here to create this perfect square trinomial would be positive 25. And it is the same as squaring x minus 5, that binomial x minus 5. All right, so hopefully you're kind of picking up on the pattern here. Here's what's happening. We're just going to do a general form here. So if I wanted to add some number to x squared plus bx to create a perfect square trinomial, I'm just going to set up a little square here. I'm going to create it like this here, and we have x times x, which is x squared, b times x, which is bx, and b times x, which is bx, and then finally b squared. Now, there are two bx's here, right? So what I'm essentially having to do is I'm essentially having to take half of the value of b and square that in order to get that last term. So in order to create this perfect square trinomial, I need to take half of b and square it, and now I'm creating a perfect square trinomial, and it's the same as squaring this binomial x plus b over 2 squared. In example 3, we're asked to rewrite the equation in vertex form by using this strategy, completing the square. However, these examples are going to be a little bit more difficult because we're actually starting off with the standard form of an equation of a quadratic. So in order to use this completing the square strategy, we're going to rewrite this first line, y equals x squared plus 18x plus, and then we're going to leave a little blank spot there because that's going to be used for our perfect square trinomial. And then we'll add in our 87. Now, let's just take a look at these first three terms, and let's create our perfect square trinomial by taking half of 18 and squaring that. Well, half of 18 is 9. 9 squared is 81. So these first three terms now, x squared plus 18x plus 81, can be rewritten as y equals x plus 9 quantity squared plus 87. Now, here's the tricky part. I added something to the right side of this equation. I actually added 81. So that's going to make my equation imbalanced. So out here, I actually have to subtract 81. All right, now let's simplify this. We get y equals x plus 9 quantity squared. And if I combine my 87 and my negative 81, that gives me a positive 6. Okay, here is my equation written in vertex form. This should look familiar to you. It fits into this template of y equals x minus h quantity squared plus k. Now, my minus h here is actually going to be a negative 9, so the vertex here is negative 9. And my plus k is my positive 6. So I say the vertex of this parabola is at negative 9, 6, and here is the vertex form of that equation. All right, let's try another example here. In example B, we see we have x squared minus 2x plus 12. So again, I'm going to start off by rewriting this first line, y equals x squared minus 2x plus, I'm going to leave a blank here, and then I'm going to add my plus 12. So now I have to take half of negative 2, which is negative 1, and square it. When I square negative 1, I get a positive 1. So these first three terms here are going to be rewritten as a binomial squared. This becomes x minus 1 quantity squared plus 12. Now remember, I added 1 to this side. So out here, I have to subtract that 1 in order to keep it balanced. All right, we are going to simplify this equation now. We get y equals quantity x minus 1 squared. And then I add my 12 and negative 1, I get a positive 11. So again, this fits into my template of my vertex form, and I see that my vertex here is at 1, positive 11. All right, for example C now, we have a little bit more of a difficult case. We see that we have a 3x squared minus 12x plus 3. So it says here, we first have to get x squared term to have a coefficient of 1. We see that it has a coefficient of 3, so what we can do is we can actually factor out that 3. Think of factoring out as like the reverse of distribution. So if I pull a 3 out of each one of those terms, I'll be left with x squared minus 4x plus 1. Okay, now we can proceed just as we did in the previous examples. So I have y equals 3 times the quantity x squared minus 4x plus, I'm going to leave a blank space there, and now it's plus 1. Okay, I'm going to take half of negative 4, which is negative 2, and square that. When I square negative 2, I get a positive 4. So these first three terms are going to be rewritten as a square of a binomial, and that goes like this, y equals 3 times x minus 2 quantity squared. Now remember, I not only added 4 to this side, but I actually added 3 times 4. So that's adding 12. So if I added 12, I also have to subtract 12. So outside the parentheses, I have a plus 1 minus 12. All right, now let's simplify everything. Our equation is y equals 3 times x minus 2 quantity squared. And if I have a 1 and a negative 12, that's going to give me negative 11. So again, I have my vertex form of the equation, and I should see that the vertex here minus h, which my h would be 2, and now it should be a plus k, and the only way to get plus k out of a negative 11 is if this is a negative 11. So there's the vertex of that equation, y equals 3 times quantity x minus 2 squared minus 11. All right, one final example for today, and this is, again, a little bit of a tricky one here. We see that Meryl kicks a soccer ball so that its height in h feet after t seconds is given by this equation. We want to convert this equation to vertex form. So I'm going to rewrite this. I have h of t, which is equal to negative 16t squared plus 40t. Now, again, that same rule applies as example 3 in the previous slide. We need to get t squared by itself, so I need to factor out this negative 16. So I'll write h of t equals negative 16. And if I pull that out of a t squared, I get t squared. And if I pull a negative 16 out of a positive 40, I'm actually going to end up with negative 5 halves t. Okay, now I'm going to leave my little blank spot there so that I can complete the square and form a perfect square trinomial. And by doing that, I need to take half of -5/2. So if I multiply -5/2 by 1/2, I'll actually get -5/4. So -5/4 is what I want to square to come right here in this third term. When I square that, I'm going to get 25/16 because I squared both the -5 and the 4. Okay, now here's again the tricky part. I didn't just add 25/16. I added -16 times 25/16. So what I need to do out here on the outside is I need to subtract back the multiplication of -16 times 25/16. Now when I multiply those two, our 16s will cancel out and I'll get a -25. So I actually need to subtract a -25, which in the end would be adding 25. Okay, here we go. We are ready to write our vertex form. Our vertex form now will read like this. H of t is equal to -16 times the quantity t minus our 5/4 squared plus 25. All right, now that's a pretty difficult one to get there. We can go over more of those in class. But finding the maximum height, remember now this is a parabola. If you were to graph this, is a parabola that's going to open down. The maximum height will be at its vertex, and since it's already in vertex form, we see our vertex here, our x-coordinate should be 5/4, our y-coordinate should be 25. So that means the maximum height here will be at 25 feet. And it says how many seconds does the ball reach its maximum height? That is going to be our t, so 5/4 of a second or 1.25 seconds.